Hey, what Grandpa is searching for? Can you identify? It's nothing but the spectacle here. Right or not? Yes. But he is not able to find it. Could you please let me know what could be the reason? Light is off, right? Yes. So the room looks so dark and he is not able to find the spectacles. But don't worry, we have the rescue person here. It's nothing but Arun is going to help him out so that he can find it really easily. But how Arun is going to help him out? Can you please tell me? Quick. No way. Exactly, he is going to own the bulb, right or not? Exactly. So that what happens? The room gets light and therefore he will be able to see the spectacles. Am I right or not? Yes. So let's get started, and here we are going to have a very wonderful session, and this is on the topic called electricity and circuits. My name is Aishwarya Sindhu Ramachandran and I will be your science educator today. And before getting into the main part of the session, please have a notebook and a pen along with you so we can note down the important points as we are going to discuss multiple concepts today. Not only that, please try to post your doubts in the comment box. So I am here to resolve your doubts. So please feel free to ask your doubts in the comment box, and let's get into the session. And these are the basic contents that we will be learning today. So let's get started with electric current, electric cell, electric bulb and its working, electric circuit, electric switch, and finally conductors and insulators. So let's get started. Are you all ready? Just give me a thumbs up in the chat box. So let's dive into the session here, and you can see that if your phone running out of charge, or if the bulb is not working, or if your TV is not working properly, what do? What is lacking here? Can you please identify what is lacking here? What has to be supplied if you want to turn on the TV, if you want to just make the work of bulb, if you want to charge your phone, what has to be supplied? Exactly, it's nothing but electrical energy. So electrical energy has to be supplied for the proper working of these appliances. So let me write it down for you. So electrical energy or electric current has to be supplied for the proper working of these appliances. Am I right? Yes. So now what we are going to learn is all about the water current in a river. Why is it needed? Don't worry, let me break it down for you. So if you consider a river, you can see that water flows, right? Yes. So water flows in a river. So flow of water can be termed as a river flow. Am I right? Yes. But if you consider electric current, then it must have a proper definition. That is what we are going to learn next, and look at it. Here you can see that flow of charges can be called it as electric current. In case of river, water is flowing from one place to another. But in case of electric current, charges flow. So how it flows? Very important, very important. What it is, what is the direction? It's from positive to negative. So you have to be very clear with this point. And not only that, SI units are very important. So standard international units is very much important to learn. So the SI unit of electric current is nothing but ampere. So now we are moving towards the next part. It's all about electric cell. So let me tell you a basic example. Don't worry. So I'm taking this AC remote, and you can find that there are two batteries here. Okay. So if I try to take out these batteries, do you think this remote works? Tell me, works or not? No way, right? Yes, because I have taken out these batteries, and therefore what happens? The remote will not work for sure. Correct? Yes. But why it is not working? Because I have cut the electrical supply here. That is what the reason the remote is not working right now. But if I try to put the battery again, then what happens? The supply has been replaced, the supply has been given, and therefore what happens? This remote starts to work again. So as in a similar way, you can see that electric cell is nothing but a source of energy. Okay, it's a source of energy. And if you consider a cell, this has basically two terminals. What are they? A positive terminal and a negative terminal. So there are two terminals for a cell too. And what about the energy conversion? Chemical to electrical energy. So this is what the conversion that happens right inside the cell. And now we are going to learn the symbol of it. Why do we need to learn the symbol? Imagine if you just try to draw a figure of electric cell directly into a paper. Is it a convenient one? No way, right? It's very difficult to draw an exact figure of a cell into a paper. So for the convenience of learning, we have made such symbols to learn in more effective way so that the symbols have been made. And if you look at the symbol of electric cell, you can see that there are mainly two parts. What are they? You can see a long line, then you can see a short line. So the long line which represents the positive terminal and the short line which represents the negative terminal. So these are the two terminals of an electric cell. And the conversion is nothing but chemical to electrical energy. So there are chemicals right inside the cell. Okay, so these chemicals are going to get converted into electrical energy. Therefore, the conversion is done. And I hope you're clear. And now we are going to learn electric bulb. So similarly, we have a sign here. So we have a symbol here. And when you try to learn electric bulb, we need to learn the symbol as well. And there are two ways you can make the symbols here. So this is another way of putting the bulb. Got it? So these are the two symbols in which you can represent the electric bulb. And now we are going to learn the different parts of it. So you can see the picture, and this is nothing but filament. Please understand, this is nothing but the filament of the bulb. It glows when electric current passes through it. So when electric current passes through the filament, it glows. And what kind of material has been used here? It's nothing but tungsten. So please write down, very important, tungsten. So tungsten is the material that we use to make the filament here. And what about this part? Oh, this is a glass case. So this glass case has been given for the protection. And inside the glass case, there is a gas has been filled. What it is? It's nothing but the inert gas. So why we filled inert gas? Oh, you could have gone for air, right? No, air instead, right? No way, we cannot use it. Why? Because to avoid the burning, we need to use an inert gas there. We know that the bulb is going to release a lot of heat and light. So there is a possibility of catching fire, correct? Or getting burnt. So to avoid that, there must be an inert atmosphere could be created so that the burning could be avoided. And we know that not only the light is being generated here, heat energy is also being generated. So heat plus light. So heat and light are generated here in case of a bulb. Okay, so I hope you are clear. So if we are going to learn about electric switch, and when you consider electric switch, this is nothing but a component that is basically used to control the appliance through on and off conditions. And when you look at it, you can see that it can either use to connect or break the circuit. So switch is nothing but a component that is basically used to connect or break the circuit. And when you look at the symbols, there are mainly two symbols here. So the first symbol is nothing but open condition. So open condition means here there is a gap. You can find there is a gap here. Correct? So if you find a gap, it's open. So that means the switch is in off condition. So once it is in an off condition, you have to understand that current will not flow. So there will not be any kind of current flow if the switch is off. Got it? And what about the second condition? You can see that there are no gaps. Okay, so there are no gaps. So it is closed and therefore it is in on condition. At the same time, current flow will be there. Got it? So this is a way that you need to identify the basic symbols, and now we are going to learn about electric circuits. So what is meant by electric circuit? So when you look at it, you can see that it's nothing but the connection of electrical components. So connection of electrical components, that means various electrical components have been connected in such a way so that it can create a circuit like this. Okay, So circuits are basically of two types. The first one is nothing but the closed one. So what is meant by a closed circuit? There will not be any kind of gaps. Please write it down. There will not be any kind of gaps in the circuit. So that what happens? Current flow will be there for sure. So please write down, it's nothing but current flow will be there. And what about the next one? Open one. So when you consider the open one, you can say that there will be a gap for sure. So what happens? There will not be any kind of so there is a gap for sure and there is no current flow. So please write down. In case of closed circuit, there are no gaps, so current flow will occur for sure. And in case of open circuit, there is gap and therefore the current will not flow. So that's all about circuits, and you have to just identify what kind of circuit it is. Quick, please. It's nothing but an open circuit, right? Why? Because you can find a gap here, correct? So if you are able to find a gap here, then you have to understand that it's nothing but an open circuit. And do you think the current flow happens here? No way. So there will not be any kind of current flow. Got it? So please understand, only closed circuits have current flow. And in open circuits, there will not be any kind of current flow. And now we are moving towards the circuit diagram. And I told you that there are multiple components like bulb, switch, cell, etc. But if you just try to draw the exact figures of these components, that's going to be extremely difficult. So for the convenience, we have figured these kind of symbols so that the circuit diagrams can be made in such an effective way so that the learning could be more convenient. So look at it. Could you please identify what kind of component it is? Please. It's nothing but cell, right? You can see that there is a positive terminal, there is a negative terminal, and you can definitely identify that it's nothing but a cell. And what about this one? What it is? Yes, it's nothing but the bulb. Okay, this is nothing but the bulb. And what about this one? The switch is in the switch, but this is an open or closed condition. This is an open condition. That means it is off. And do you think the current flow happens? No, no current flow will occur. So no current flow will occur. Okay, so that's how the circuits are being made, and please understand, only in closed circuits current flow will occur. And we know that materials are basically classified into two, as conductors and insulators. So when you consider conductors, these can allow electric current to pass through. So examples, metals. So metals can definitely conduct electricity. So gold, iron, silver, all of these are considered as various examples of conductors. But what about insulators? Materials that does not allow electric current to pass through. So plastic, glass, rubber, all of these are various examples come under the category of insulators. And now we are moving towards a summary, and here you can see that we have completed electric current. It's nothing but the flow of charges. Then we discuss electric cell, which is nothing but a component that can be acting as a source of energy, and electric bulb and how it works. Then we discuss electric circuit. This is nothing but the connection of various electrical components. Then we discuss electrical switch. It's nothing but a component that is basically used to control or connect or break the circuit. Correct. And finally, we discussed conductors and insulators. Conductors can conduct electricity through it. Insulators are not going to conduct any kind of electricity through it. And finally, we have reached the end of the session, and that's the end of the class. We'll meet next day with an amazing session similar to this. Have a nice day and goodbye, everyone. Thank you so much.